Hi everyone. We'll continue with chapter 2, and if you know anyone who took algebra or pre-calc, this is going to be familiar. It's more of strengthening the ideas of a function and function notation and the graphs. Of course, there is a correspondence between an x or an input and a y, or which is an output, or a relationship between independent variable and a dependent variable. And that's a function kind definition. But here it's one. Let's see. So the relationship is one and only one, which means each x has exactly one y. And an example for it, this function x squared. If you take an x has exactly one y, so this is a function. And also it passes the vertical line test, which we will see. So the domain is all the values in which this function is defined. So for example, this function, the domain is all real numbers, where for example, g of x equal 1 over x, it is defined in every number except 0. So the domain is all real numbers except 0. And if an x element in the domain, then the element in B that associates with x is written as f of x. So, and this will help strengthen some ideas. So if you see f of x, we also indicate the output or the dependent variable or the y, right? And so the domain is where the launching place for the function, and the range is where the outputs are, or all possible outputs, the range. So the range, we have the y values, and in the domain we have the x values. All right. So here you want to ask, of course, if you ask yourself about that definition, if there is an x and it has more than one y, is it a function or not? So example, if we have some relationship where x leads us to y1 and x leads us to y2, in this case, not a function. Why? Because x has to have just one y. And you get more examples. So for example, an area is given in that form, so every x will have an area that is x squared. Is similar to the example I just gave. And of course, the function notation, f of x stands for x being the input. So if it's f of 1, means 1 is the input. So you won't think about this as a placeholder, and f of the placeholder. And the interesting one to talk about is this a plus h, so you get used to it. And I'll show it here. A plus h, so you see 2 squared minus plus 1. So we put the a plus h now this is the input, goes in there. And so once you set it up, then you do the math on it. So this is a plus h squared, which means a plus h times a plus h. and you FOIL it, or there is a shortcut for it, which is this way. All right, then we distribute a 2, so there is a 2 there, and that will give us a 2a squared plus 4ah plus 2h squared, which is this part. Then now you see this negative a minus h plus 1, and then you see if there are anything to combine, by in this case non-Sewellian. So to determine the domain of the function, mostly you're going to talk about some 3 restrictions. Then there is a 4th one with logs or logarithmics. And so, of course, with the video, you can, if you want, go through the notes. I will post these notes as usual. But, you know, you can pause the video and go through the notes, because for me, I try to kind of explain in general, so we not reading through the notes here. So when we talk about the domain for these kind of algebra functions, if you want to call them that way, a simple way, then usually there are some restrictions to talk about. The first one I gave example for is you cannot divide by 0. So the domain is all numbers except 0. Another simple one is this, square root of x. X cannot be a negative value for graphing. If it is, then you get imaginary number. So x must be greater than or equal 0. If you get a combination of the two, it cannot be 0 because you divide in and it is in a square root. So in this case, x is greater than 0, like strictly greater than 0. You see there is no or equal. Then there is another one, for example, logarithmic of x. X also must be greater than 0. So you can try x to be 0 on your calculator. For the log, you will see an error. And you can try like 2 negative and you do log and you get error. So there's some simple ideas that everybody needs to know as a common knowledge, right? And if you know these, it's going to help figure out the other domains. And of course, they are, while we do these, there are some that if it's linear, the domain is all in numbers. If it's a parabola, the domain is all in numbers. If it's polynomial in general, right, the domain is all in numbers. So there are some functions that we should know just as we work on these. So if we look at this A, and we look at f of x and for b and c. So similarly here, this radicand that is inside, just like I set up in that note, this must be greater than or equal to 0. It has to be positive, which means x is greater than or equal 1. So this is the domain. When you graph this function, it's going to be graphed over the values from 1 and up. For this b, you're dividing, so we want to make sure we're not dividing by 0. So if you want to investigate, you set it to 0. And you get x equal negative 2 and 2, which means these are the problem numbers. So that's the ones we don't want. So to talk about the domain, we're going to do not equal to. So you find them that way, then you say, okay, that's the numbers that should be out. So the domain here is all numbers except negative 2 and 2. And as I just mentioned in the note, this is an x squared quadratic thing. So it's like a parabola for this function here. It's a parabola that's shifted up by 3. So this one is just going to be all real numbers. That's the domain. So this is how you should start looking to these. And here you get the interval notation. So it's interval notation when you put it on the line. If you put one here, then we're saying this, right? So it's 1 to infinity. And when you talk about two values that are out, if you put them on the number line, then you start to see that every other number is okay, except these two numbers. So if you want to do the interval notation, it's negative infinity to negative 2, negative 2 to 2, then 2 to infinity, right? So that's how you figure out, you can do the visual to it. And for C, there is no problem there, so we just say that's the domain. And of course, we know that if we want to graph a function, we're going to use the x and the y values, and often we substitute the values into the function to come up with the graph. And here, if f of x is negative, then negative f of x gives the depth of the point. The depth means, you know, how far it is as far as the height. And this is like for the absolute value definition. If, you know, the absolute value of x is same as x if x is positive, right? It is negative x if x is negative. So this is something we often do because when you try it with numbers, you know, you can try it with numbers and see. It's 5, right? Since 5 is positive, you know, 5 is greater than 0, you do it that way. But if it's this way, then the answer has to be negative 5. So that's what the negative stands for. If it's negative 5 less than 0, right? So the answer is 5 because of this. So that's how it's figured out actually. So when you see if f of x is negative, then negative f of x gives the depth of the point xy. So I think this is not a problem. So if for this blue graph here function, and if it's stuck here and here, it's not continuing, then the domain is the x part in which it's defined. So you do the projection, and the range is its lowest point, which is this one, and its highest point, which is this one, and that's the range. And of course, you want to be careful whether this is this, or it's this, or it's this. Here means it's ends, but it's included. It ends, it's not included. It doesn't end, it keeps going. So, all right, a few things practice for you, so you get used to these ideas here of the graphs. If you're asked what is, so two things that you need to know here. If you're asked what is f of 3, that means you're asked about the y value, right? That's the first thing mentioned. And then if you're asked about f of x at 3, right? Then here, x is unknown, but 3 is the y value, right? So you want x that has 3 as the y value. So keep in mind whether it's inside or outside. So, so 3 here is the y value. We're going to go to 3 as the y value. And we're going to say, in this case, x is 5. Because at x is 5, we find that the y value is 3. For this one, what is f of 3, right? Means x is 3. So what is the y there? It's -2. So this is just how you read the graph and how you put the values in the graph. And this is, let's talk about these. Since the point 3, -2 lies below the x-axis, we see that the depth of the point is 2 units, and of course that's, so the depth means kind of the distance down, or so we made it positive. Okay, so we go back here and let's talk about the domain and range, so we understand what's going on. So domain, we're going to start far left. It looks like it ends here, and we're going to keep going until this thing ends, right? Right, so that's the domain. So it's -1, 7, and that's brackets because they're both included. And the range, we're going to start the lowest point and go up to the highest point. So this is the domain, and the range is -2, which means the y values, to 7 included. You see, they are included because of these, and -2 because here it's included. And that's what this talks about here. And piecewise functions are, here is an example for a piecewise function, means there are some rules to it. For example, if x is less than 0, it takes this form. If x is greater than or equals 0, it takes this form. This is same, this is one function. It just has different rules, right? And we can graph it here and see. All right, and so think about this. X is less than 0, the graph is -x. So this is where x is less than 0. The other one is the square root of x, as x is greater than or equals 0. So it is included there. Okay. So you see, they're the same function, it's just they have two rules. So now if you're interested in, of course, the subdomain of each part we know. This one just goes -infinity to 0, and the other starts from 0 to infinity. Those are clear in the graph, and they're given actually in the piecewise function. Then if you use values, you get these, and you can find whatever information you want after that. So the vertical line test is we can test and figure out if something is a function or not. So I mentioned that for this, for example, if you do vertical line test anywhere on the domain and it crosses it in one point, not two, one point, then you say yes, it's a function. So for example, a circle, and if you try that again, it fails. Here the circle passes 1, but here it fails 2. So no, not a function. So that's one idea that this thing is useful. So you see this one is crosses it in two, so this is not a function. It's a relation, and its equation is y squared equal x. And you can see, of course, here that for the x has two y's. So for example, 9, the graph I did has -3 and has 3, right? So it does not have that one-to-one relationship for it to be a function. And of course, you can try different examples and see. Let's take some examples and talk about them from the homework. This is number 2. This is a practice for the function notation. If you have a function g of x as -x squared plus 8x. So for example, what does it mean to have this? It means that now the input is that, right? And as I mentioned previously, you're going to need to do a squared for this one, a squared plus 2ah plus h squared. And for this one here, you're going to do 8a plus 8h. And then you will need to multiply by a negative there. So you get -a squared minus 2ah minus h squared plus 8a plus 8h. This is just to substitute -a, right? And -a times -a is a squared, same, right? And this negative is still there, and this is just -8a. So the answer here is -a squared minus 8a. A square root of a as input. These two cancel. All right. So look at this one here. It's a plus g of a. It just means you have g of a pushed by a, right? It doesn't mean, you know, something impossible. It just means you have a plus what is g of a, right? And g of a is use a for the input. All right, so and as you see, plus 9a. And of course, if you want to do some reason a factored form, it's going to be -a and a minus 9. So you can factor as well that. So 1 over g of a, what does it mean? It's just reciprocal of this function with a being the input. So a squared plus 8a equal 1 over -8 squared plus 8a. And similarly, as I mentioned with this one, if some reason you need to factor -a, you get a minus 8. Okay. Similarly here for let g, and I'll look at what number is this one. Probably number 3. And you know, it's just to help strengthen these ideas here. So when you look at g of -6, you're going to ask, based on these rules, where does -6 apply, right? So for here, x is greater than or equals 6 means 6 and up. And here, not including the 6 and down, right? So -6 applies to the first one, g of -6, -1/2 to a -6 plus 5. And okay, so we get 8. Then g of 0, same thing, we're getting a 5, just like a -6. You see g of 6, it's included here in the second one, so 6 minus 6 is 0. And now g of 12, it's in the second rule, it'll be 12 minus 6, which is the square root of 6. Okay, so let's look into this function. It's given us a graph, and talk about a few different things. F of, for example, 9 is going to be 1, right, from that point. And let's say we have a height as, for example, 5, the height 5. You have two values, a 4 and a 6. So f of 4 is 5, f of 6 is 5. So 4 and 6 allowed to the height to be 5. And of course, 4 is the smaller number. What is the x-intercept? It's going to be this value here. So 2 is the x-intercept. And of course, since it's x-intercept, y there is 0, or should say f of 2 is 0. All right. Y-intercept is this value here. -2 is y-intercept, which means x there is 0, or f of 0 is -2. What else? Let's talk about the domain. The furthest point on the left is this one, and we're going to keep going until the graph ends. So -1 to 9, that's the domain included. The lowest point is this -2, and the highest point is this 6, and that's going to be the range for this thing, right? I think this one is okay. Just sketch the graph, right? And I'll give you a second to think about it. It's just a matter of doing two graphs on the same coordinate system with x less than 1 and with x is greater than or equal. So if this is f of x, so for this part is -x plus 8, and this part 10x minus 3, and of course you're going to put the same system. You're going to go to that critical point 1, and for here the intercept is say 1, 2, 3. let's say 8 is here, so down 1/1, it's going to be something like this. And for the second one, it's if you want to start even from here, you can, but I'll show you that of course we're not going to keep it. If you say the y-intercept is -3 and the slope is up 10, 1, 2, right, and over 1, you can, which will be here, but you're not going to connect from here because it's only defined at x greater than 1, right? So if you graph it like this, then you're only going to graph this side of it, something like this. I didn't do it to scale, but I think you should, you're going to pick the one that is correct that way. Okay, so this problem is, I think it's somewhere the last one, like number 10, right? And so if you read it and see, we of course, I discussed in a previous video something like this where a model is used and there is a reference. And here, the important here is this reference t measured in decades, right? And a decade is 10 years. With t equals 0 corresponds to 1900. So 1900 is a t equals 0, and the 1960, that's 60 years, right? Which means that's 6 decades, right? Then at the beginning of 2000, 2000, it's 100 years from the 1900, which is 10 decades. So this is the important part. Before you start doing any calculation, you want to understand the setup. You want to understand how this functions, just like if it's a bicycle, right? How does the bicycle functions? It's that way. When we understand how it functions, then we start operating or using it, or riding it or whatever. So if we understand that part, that means for the first one, this t equals 0 fits here. So we're going to use this thing here. And for the second one, the 6, we're going to use this because the 6 is between 3 and 7. And for this last one, we're going to use this. Okay. So this is just a matter of calculation, and I'll give you the numbers. So you should be, pause the video and try them and see if you get these numbers. And with the calculator, got about 22.9 years and 29.5 years and 35.4 years. And of course, if this thing asks to graph, you can pick the best graph. The first one is like a line, right? And the second one is like a parabola that opens down because of this value that is negative. And the other one is, it has a much bigger slope. This 1.3, this is 2.6. So you expect some type of graph that is like that, right? And this is f of t, and this is t. Okay. Thank you.